All right, well, I'm waiting for everything to catch up. I got a lot of lag tonight. I don't know why. So I'm sorry for that, and I don't want to check my stream. I tried to transition in, wouldn't transition, so I'm going to mess with it for just a second and see if I can figure out what's going on. There's everything. It's just all catching up. And I know the reason. Got a little bit of lag. I can see it in my... Maybe it's not in the stream, but I think it is. Okay, so I've just checked on my phone to make sure that my mic is good. So I'm coming through okay there. Everything seems to be going okay. I'm going to proceed on, but I'm really disappointed. I had everything up and going. And I always try to start, I'll talk about what we're going to do tonight. I have a 2015 iMac, 27 inches, fantastic. Beautiful screen, does everything that I need it to do. But when I go to run Ecamm, and in this case I've got Keynote up because I've got something running in the background. You've got all these processes going, these Adobe stuff in the background. Hey Artemisia, good to see you. Thanks for stopping by. I've got all this stuff going in the background. So all of, trying to multitask, just writing, right, I got your name down. All of this stuff going on this 2015 Mac, and I don't know how to minimize these processes. Like Mac is a little bit different than PC where you kind of take it down to bare bones. I'm sure there's a way. I don't know. So here we go. I've got Keynote up, showing. I've got my iPad connected through Doceri, another program that's just a major hog when it comes to resources, and then Ecamm, which is not a major hog, but is right up there with the other ones. So I'm going to take a look right here at my Twitch stream just to see how the movement is going. So I'll be just a second, but not long. Twitch, you got to go all around your elbow to get to stream. It actually looks like it's streaming okay, even though up here I look a little bit like I'm moving like this. So, all right. So I'm going to leave that phone right over there. On top of everything else, my iPad, which I stream through Doceri to there so I can write and do things like that, is at 12%. If that tells you where I'm at on this Tuesday evening. So, okay. So let's get started. I stream through my iMac using Ecamm, which is for the Mac computer. It's kind of an overlay. It's like OBS, except everything's built in. It's a fantastic program. Costs a little bit of money, not a ton, but costs a little bit. I don't mind paying it because I enjoy using it. It's a very good program. I also use Restream, which I go through the browser for. that becomes even more of a little bit of a hog in there with stuff going when I've got my Google Chrome browser up with too many tabs. What we're going to be talking about tonight, I've graded the test. I put them in the system already. I think I listed what the mean and standard deviation were. I think the mean was 71 on the test, and the standard deviation, I think, right off the top was 17. It was a little bit better than on some of the quizzes, but so we're getting there. And some of the scores may not be what folks want, but this is a way to catch it up. I think I put in the announcements that if you come in tonight, if you interact, if you be a part of this, then it's plus 5 points. And we're going to do something in class tomorrow night, too, to kind of hit some of the points from the test that I think were missed by students overall. Part of that's what we're going to talk about tonight. Hey, Gunn, what's up, buddy? Thanks for stopping by. I appreciate it. I do appreciate it. Thanks. But we're going to do, and he's coming in from Twitch, so you guys may not see, like I'm talking to nobody, YouTube land and vice versa. But anyway, so I'm going to talk about empirical rule and z-score and a little bit of a z-score review. So empirical rule review, z-score review, and let's get started. You're going to be amazed. I'm really on top of my game. I told you I wanted to make this more professional, and other than my lag and being here a little bit late tonight, I think I'm doing okay with this. So now I got to figure out. I think I can scroll this, but oh, I know how I can do it. A pointer up here. There we go. All right. So here's the first screen that we've got. I'm going to give it a second to come up, and there it is on my screen. Oh, boy. It's not here. It's not here yet, but I do see it up on mine. And that's behind, so as soon as I see it pop up on the screen, I'll get started. So if you've got a bell-shaped distribution up on your screen and a problem, then you're in the right spot. I don't seem to have it here yet. It just hasn't transferred over. I may rage in a moment. This is really frustrating. I got absolutely nothing up here on Ecamm. I've got it up here. I've got it here. So I'm good to go, and I'm pushing it out. Let me look at preview mode. There it is. Yay! Hallelujah! I don't have to rage quit after all. Although I wasn't really going to, but I could feel it bubbling up like the Hulk. All right, now let me just double check. It's up here. Let me make sure it's going out to you guys. Artemisia, if you see this, or Gunn, if you see a bell-shaped distribution up in the upper left and a problem over there to the right, just let me know. I got everything showing here now, but it just hasn't popped up on my phone yet, which is what it looks like on Twitch. So keep me posted if you would, if you're if you're active right now, and just let me know when this pops up, and then we'll get started. We'll talk about just a couple of problem sets here. At least I still see me moving in the Twitch screen, so that lets me know that it's still streaming. Nothing in chat. Let me send a different chat message, see if it pops up, and it does. So we're okay there. Oh, there it is. Now it's up. So I'm going to go ahead and get started. So here we are. So I hope everybody can see this okay. It shows up very well on my iPad, very well on the screen, and very well up there. If you're using a phone, I've got it on my phone. You might have to pinch and move towards that upper corner. But we've got a bell-shaped distribution. So you've got just mess it up on my screen. There it is. 99.7% between -3 and 3. Thank you. Appreciate it. I have... Oh, now it's gone. There it is. Okay, so 99.7% from 3 and -3. So that's how much data falls between 3 standard deviations on either side. 95% between 2 standard deviations. 68 between 1 standard deviation on either side. Empirical rule. We've talked about this. We've also talked about... Thank you, Artemisia. We've also talked about the fact that we're going to learn much more about this when we break down normal curves in more than just an overview with empirical rule guiding us. So once we get to that point, we're going to be all right. So I've got a problem here that I want to talk about with respect to the bell-shaped distribution and the empirical rule. So you got the mean value. My screen keeps flickering. Got the mean value of land and buildings per acre from a sample of farms is $1,500 with a standard deviation of $200. So I'm going to go ahead and do a little bit of an overwrite here. Even my iMac wants to be slow for Mike. Okay. That looks nice. It may be time for me to get a new Mac. Just saying. So the mean value of land and buildings per acre from a sample of farms was $1,500. So the mean was $1,500. Okay. Standard deviation of 200. So I'll go right here to the side. Write the standard deviation. Estimate the percent of farms. And remember, with the empirical rule, we're talking about what percent of the data lies between here and here, here and here, here and here, and so on. So estimate the percent of farms whose land and building values per acre are between 1,300 and 1,700. Assume the data set has a bell-shaped distribution. No problem. Here's what I'm going to do. I'm going to sketch one. Let's see how this goes. Not too shabby. I kind of dicked it up there on the right side, but that's okay. So in the middle is the mean. So there's our 1,500. And we go out 200 on each side, down 200, up 200, and that gives us 1 standard deviation, 2 standard deviations, 3 standard deviations away. Okay, good. Okay, I'm glad I can see it. Or I'm glad you can see it because it just keeps going white, going out. I don't know what to do. So I go up 200 from 1,500 and I am at 1,700. I go up another 200, I'm at 1,900. Another 200, I'm at 2,100, right? Drawn very poorly at the bottom. I apologize, but I'm down there. Hey, Victoria, got you. All right. Isn't it great on a Tuesday night to be talking about statistics and not doing anything fun or with families? Isn't this great? Just kidding. If we go the other way, 1,500, so you got 1,413, so you got 1,300 here. I'm going to go up above just because, only because I'm running out of room. There's no significance to that being above other than that. I go down 200 more, and iPad is in low power mode, by the way. It's great. 1,300, 12, 1,100, and then 900. So there's what we're looking at. And this just breaks out to be, this middle point is the mean. It's 0 standard deviations away from the middle. This is 1 standard deviation, 2 standard deviations, 3 standard deviations. This is 1, this is 2, this is 3. This drawing is just a sketch. It is not drawn to scale. Those should be the same distance, like lattice points on either side. They just don't happen to fall that way. Our question here, is estimate the percent of farms whose land and building values per acre are between 1,300 and 1,700. Okay? Let's do it. 1300 is here. 1700 is here. The area in between is from 1 standard deviation to 1 standard deviation on either side. That within the empirical rule is here. And that is simply 68%. So a very, very simple problem just to start us off with empirical rule. If you have any questions, throw them out, or if you want to see something different, I'm glad to do it. If you got it right on the test, just sit back. You're here. 5 points towards test. No problem. So I'm going to move on past this one. If there's any questions, again, just shout them out in chat. Oh. I don't know what I just did. There it is. Okay. I forgot I've got to exit out. Boy, I'm just off. I had everything planned too, folks. I was in here 20 minutes early, had everything rolling, then had to reboot the Mac. I hate to keep complaining about that, but it's killing me. All right. Of course the Mac doesn't like that. Let's go here. Yay. On top of everything else too, wait till you see this next screen. Like a dummy, I used a dynamic keynote presentation, so the background is moving, thus causing it to take up more. Hey, Tiante, thanks for stopping by, bud. Thus taking up more of my resources on the Mac. I hope everything's going good, guys. Basically, tonight I'm talking about empirical rule, doing a little bit of review from some of the stuff that was missed from the test, which all the grades are posted, everything's out there. Sent the announcement for this, 5 points toward the testing category. And I want to talk about a few things. But mainly tonight, I have complained about my older Mac, my iPad being low, and everything else. So hopefully this stream is showing up okay. Every time I get off, I always go back and review it. So hopefully it looks better than it does for me in my preview screen. Let's take a look at this. Bell-shaped distribution, I've got that, I don't know, that bell-shaped curve in the corner that breaks it down for you. This is empirical rule. I always find this to be a good breakdown picture of it. Now we've got another problem here that says the mean value of land and buildings per acre from a sample of farms is 2,400. So the mean value is 2,400. So let me overwrite here. Okay, so you got the mean is 2,400. Standard deviation is given as 450. I don't think I had read that, but reading on that sentence, that's where it goes. Between what two values do about 95% of the data lie? It's as akin to the previous problem. It's just written differently, right? So we are, I can't, let's see, I'll try this. Trying to see what shows up. That doesn't show up very well. So here we go with the curve. Let's see if I can keep it. That's okay. So I've got a sketch of a normal curve. Unfortunately, I was a dummy and I put dynamic background and I put the color green back there. So overriding it doesn't look real good. But I'm going to do some yellow in here. Try to make it stand out. Maybe I should go also with darker blue. That might help. So right in the middle, yeah, that helps. In the middle is the mean. That's 2,400. If I go out one standard deviation to the right as I'm facing it, that's plus 450. So I've got 2,850. If I go back the other way and take 2,400, subtract 450, we'll take away 400, I'm at 2,000, and then take away, was it 450? Yeah. So take away 400, I'm at 2,000, and take away another 50. And what am I at, 1950? $19.50. 20, 21, 22, 23, 50, 2,400. Yeah, added on my fingers. All right, so there we are. What I've got here is, for measures of position, that middle right there is the mean. This is one standard deviation away, and this is one standard deviation away. And they're asking us between what two values do about 95% of the data lie. Well, 95% of the data I'm not far enough out, am I? 68% falls where I've gone here. We need 95%. Sorry, misinterpretation of that problem. So let me do one more out here. So for 95%, I need 2 out. So 2850, 2850, 2850 plus 450 is at 3,300. And then use a handy dandy calculator to very easily subtract off 450 so I don't make an error to make this stream any worse than it was. 1,500. So now I'm at the right spot. So this is 2 standard deviations away. This is -2, and that just indicates direction by the negative, but that's 2 standard deviations on either side. The area in between makes up 95% of the total area under that curve. Between what 2 values do about 95% of the data lie? Well, that's very easy. It's that 3,300 and 1,500. So if I had to write this out, I would say 1,500 to 3,300. Okay. Hope that helps. Okay. Again, 5 points to folks who show up tonight. I appreciate you showing up to kind of take part in this. I will mention along the way little things like there are my stat labs out there. Try to do a little bit of that each night. The biggest part of it, in my opinion, is do as much as you can before our Wednesday night class. So if you have questions or aren't sure how to start one or need me to talk about some of them, I'm glad to do it. I can do it in the streams or I can do it in class, either way. It's just a good way to get a little bit of feedback on some of the work that you might have been doing either wrong or right and just aren't sure. All right, let me back off of that. Okay, now I'm going to try to... No, it doesn't like that. Why would it? Click back up there. Click there. Yay, it went straight there. Still slow here, slow here. Somebody from way across the world, some genius is looking at this thinking, what is, this guy needs a new computer. I'm not even sure that I need a new computer. I think part of my issue is over the years, I've got programs on here that are loading up at startup and they're hogging resources. The problem is, even though I know Macs very well, I don't know the inner workings of it. So when I bring up stuff to force quit and make it go away, I don't know if I'm taking away a process that's needed by the Mac, and sometimes I do that accidentally. So, okay. I hold up my hand and I see it here, and that's not yet caught up. There it is now. And so let me see if on my stream, still not caught up on the stream. All right. So I had somebody come by. Let me, while I'm waiting for it to update on the screen for you. Somebody came by. I wasn't sure of the name. I don't know if it's in class or not. Butterfly Book Lover is what it looks like on the Twitch stream. I tried to add the chat up there just so folks could see, but it's okay. I'm not getting much out of this. It's killing me. So let me go ahead and get started with this. So whenever we catch up, we'll be okay. Now I'm looking at z-scores. So I've gone from a couple of questions on the empirical rule. Now I want to look at z-scores. This is very similar to what we had on our test. Similar. So we've got a standard z-score. Do some overwriting. And let me get this. So if you see right up here, I've got kind of a breakdown. The standard score, or z-score, represents the number of standard deviations a given value x falls from the mean. We've talked about that even in the empirical rule. I've talked about that. To find the z-score for a given value, use the following formula, as given in class as well. So, oops. Z just equals the x value. Whatever that x value is, subtract the mean divided by the standard deviation. Right? So it's the number of standard deviations a given value falls from the mean, okay, given the information that we have, which is the mean and the standard deviation. So comparing test scores, let's take a look at a couple of these. For the statistics test, one second. Here we go. For the statistics test scores in exercise 37, the mean is 63 and the standard deviation is 7. So I've got some information where the mean is, what was it, 63, and the standard deviation is 7.0, or just 7. Oh, put that under my big head, so let me redo that. There we go. Is 63, and the standard deviation is 7. That's for statistics test scores. Now I'm going to leave it right there. I'm actually going to do this a little bit different. I'm not worried about comparing the biology and stat scores. I'm just worried about finding the z-score right now. So if I've got that mean right there, and in exercises 39 through 42, you are given the test scores of a student who took both tests. So we've got a randomly selected student that took both tests. Again, I'm only working with the math scores here. Transform each test score to a z-score. Determine on which test the student had a better score. Let me draw a picture here of the normal curve, which we haven't gone into detail about. We've only talked about empirical rule. And let me just draw the horizontal for it. So you know that above each one of these lines is going to be a normal curve. I hesitated to draw it. That's actually okay. Let's say that we have a normal curve on top of a normal curve. Let's talk about data in this top curve. And in the bottom curve, we'll talk about z-scores. Right? So in the top curve, we've got the data which was given. We've got the mean is 63. We've got one standard deviation would take you out to 70. Another would take you to 77, and so on. If you went backwards and went 7 back, you'd be at, what, 56? And if you went 7 back again, you'd be at 49, right? So there's 2 standard deviations on each side of the mean, which is 63. Okay. When you transfer these to z-scores, you're mapping it down to a second normal curve. It's the same, except instead of the 63 there, what would be here? It would be the representation of how many standard deviations from the mean you are. And at 63, you're 0 standard deviations away from the mean because you are at the mean. When we go out 1 standard deviation away to 70, if we map that down, like we've already mapped this one down, if we map this one down, then we are sitting at 1 standard deviation away. If we map this down, then we're sitting 2 standard deviations away. I'll just continue since I'm already on a roll. If we map this down, we're at negative 1 standard deviation just in that direction. If we map this down, then we are at 2 standard deviations in that direction as signified by the negative. In other words, less than the mean. All right? So we're just mapping these down. If I found the z-score at each one of these values, right, it's going to give me what I mapped it to. So in other words, if I want to find the z-score at 63, then I have x, subtract the mean, divided by the standard deviation, 63, subtract the mean of 63, divided by 7. I end up with 0 divided by 7, which is a big fat 0. So how many standard deviations away from the mean are we at 63? We're at 0. Well, we map that. Those are easy ones, right? In the problem that we're given, you've got different numbers on there that we're going to map using z-scores, right? So let me get to that. So hopefully this helps a little bit. And again, these stay out there for video on demand. I try to post them up on the Moodle. I don't know if that's confusing. If there's a better way to do it, please let me know. But I just kind of map it so I can keep up with it. And you can go to my YouTube page at any time and find these. Hopefully they're helpful. If they're not, then never visit again. But if they are, stop by and just kind of scroll through and see if it helps you with some of the problems. But the mapping of it, that's what we get into in detail when we go over the normal curve. But sometimes it helps you here to kind of understand the larger picture. Okay. So now let's look at the problem itself. I'll run through these and then I'll probably call it a night unless there's any additional questions. So let's do this one. And again, I'm only working with math. So a student gets a 75 on the statistics test. Okay. If the student gets a 75, then x equals 75. If I want to find the z-score, in other words, how many standard deviations away from this mean that we are on this particular math curve, then I would use the following. I would have x subtract mu divided by sigma. I recommend, and I don't know how many of you have had a statistics, but not a stats course, you're in one, have had a physics course, but writing down the formulas as you go and then filling in, to me, helps reinforce it and bring it together. Now, you don't have to. I typically don't require too much of that past the first test as we go forward, but it helps kind of reinforce what you're working with, in my opinion. X is 75, subtract the mean of 63 divided by 7. Well, 75 minus 63 is what, 12? No, it's 8. So I got 8 divided by 7, right? Is that right? No, Mike, you're so dumb. 75, so you got 5 back. Then it is 12. I was right the first time. Shouldn't have second guessed myself. So 12 divided by 7. Well, 7 goes into 12 one time. We'll round that to 2 places. We got 1.71. So that's your z-score. That's how many standard deviations away from the mean that this test score is. And that's it. Again, this section is not about what's down there at the bottom. One second. I added this earlier. Butterfly Book Lover that had sent me something from Twitch, and I was making sure that this particular name didn't belong to somebody in the class, and if they're from elsewhere, it's fine. It's no issue at all. But I was just trying to make sure I hadn't missed somebody's name for the 5 points. So if it is somebody from class, please let me know. Okay, this section is just about finding the z-score. The previous, we talked about empirical rule. We're finding the z-score. Later, we're going to put it all together in the larger picture of the normal curve. I keep talking about that, and that's all I got to say about that. Okay, let me do another, and then unless I've got any questions, I'll kind of draw it to a close here. Let me, daggone it, Mike, you just erased everything out. The mean for the stats, 63, standard deviation 7. I am going to go through one of these with the other. So this is for math. And then for the, well, the mean is 63. Standard deviation is 7. That's for math, right? And then if I go for the biology, mean is 23. Ouch, not good. Standard deviation is 3.9. Okay, so that's for bio. All right. So I'm going to compare these this time. So transform each test score to a z-score. Determine on which test the student had a better score. Well, on math, in this first one right here, we've already done the math. It was 1.71. So for math, the z-score was 1.71. Okay. So for bio, let's determine what that is real quick. So the z-score is equal to x minus mu divided by the standard deviation, right? The x in this case is 25. There it is. So now we go 25 subtract 23 given here divided by 3.9. All right. 25 minus 23, I can do that in my head. 2 divided by 3.9. That's going to be a 2 divided by 3.9. I want to get a bit exact. So I got 0.51. I'll just do it to 2 decimal places. So 0.51 is what I've got. So for bio, the z-score is 0.51. Now the question from up here in the instructions is, determine on which test the student had a better score. Well, we don't know what the scales of these tests were, but we know how many standard deviations away from the mean each fell. The natural response would be to say that he had a better math score than he did bio, but again, we don't know the scales from this. So let's look at it from I'm just going to draw the horizontal, and this will be for math, and this will be for bio. Hope this makes sense. So if I've got 0 here, 0 here, 1, 1, 2, 3, 2, 3. All right, so on the bio, you were here at 0.51. That's how far away from the mean you were in the positive. So good job, you were better than the mean, but you didn't do fantastically better than the mean, it doesn't look like. On the other side of the house, on the math side, we were at 1.71, so we're out here. So when you're asked, determine on which test the student had a better score, they did have a better score on the math, but the reason for it is because their z-score, their measure of position, is further out. So they had a better score comparatively with everybody else on that math test. So, and fantastically enough, at the end of this stream, the stream looks great. I see it down here, it looks great. But at the beginning, boy, I just about rage quit twice early on going into this, and I apologize for even saying rage quit, but that's where I was at, I'm not gonna lie. So I had 3 folks stop by, Artemisia, Victoria, and Tiante. All 3 stopped by. I appreciate you guys stopping by as always. If you haven't followed the stream, go ahead and follow. Anytime I'm up here, it'll bring you back. Won't bring you back, but it'll give you an alert and come by where you can see that there's a video or something that's been added up there. Because I do add calculator videos and things like that when I have time. I try to do those weekly. I fall short some days. So that's all I've got tonight. What I did was I went over z-scores. I went over empirical rule. I talked about rage quitting, and I talked about my my setup here for the stream. I also talked about my stat lab. Be sure to get in there and work those. There will be no vocabulary quiz this Wednesday, but I will have a short work session on some of the things that I covered here. So hopefully you're up for that. All right, and with that, I'm going to close out the stream. It's been just about 40 minutes. I appreciate you 3 showing up. There was actually another person that came in on the Twitch side. 2 people that came in on the Twitch side. I knew one of them. The other one I wasn't sure, but hey, welcome. Thanks for stopping by. I do these most times during the semester on Tuesday and Thursday surrounding our class that occurs on Wednesday. All right, and with that, I am out. And I appreciate you guys stopping by, and I appreciate you guys tolerating my long rambles on my stream. All right. Have a great night, and I will see my class tomorrow up in Russell 105. Yeah, persevering. I persevered that I didn't smash my screen. I'm not going to lie to you, but thanks, Victoria. Yeah, I'll see you guys in Russell tomorrow. There it goes. Well, it looks like I am.